Hello everybody. Today you're back with me again อาจารย์ปัทมาพร at เกษตรศาสตร์ University Bangkok Thailand and this is our 7th topic and this is going to be a short one because it's on the so-called topic of source transformation. Okay, well this is simply another way to make your analysis simpler. Okay, it really requires your skills to be able to spot that if you do a transformation, it will make your circuit easier to understand and solve. Pretty much so. So the word transformations in this case, source transformation is you can change your water source into a form of current source, and you also can change or convert a current source into water source. Okay, so to be able to do that, you have to realize that when you have a source, okay, so first, if you want to convert the voltage source to a current source, okay, you have to spot in your circuit that you have a water source, okay, and it's connected in series with a resistors RS in this case, okay. Then you can, so that means that you can transform this voltage source and this RS into a current source by okay, you simply relocate your RS, okay, source resistance, I would say, okay, into parallel to the current source. Okay, so from the voltage source, it changed to current source, right? So this current source, you reposition your RS to become parallel, okay, to your current source. Okay, the current source values, okay, you simply use Ohm's law, right? I equal to V over R. So therefore, the current source value becomes simply Vs over Rs. Vs over Rs, so as you've seen here. So therefore, this is you have transformed the voltage source into the current source. Okay, so for example, so in this case, right, okay, if you think that I'm going to put this as well, this is terminal AB, okay, terminal AB. Well, I'm going to transform this, okay, into the current source. So I draw the current source, okay, the value is, well, Vs over R, so Vs is equal to 2, Rs equal to 5, so therefore become 2/5, okay, and you relocate your R, okay, so and then you reconnected your 3 ohms in there. Okay, so that's the case. Okay, well, to prove that you will get the same when you change from voltage source to current source, you get sort of the same answer. So if I have, so in this case, let's say that, okay, so this picture right here, okay, so we draw this, and if this is actually connected to a load R, okay, and I want to find the current that goes through this load IL, can go through this load IL, okay, through RL. So in this case, if I have this picture with water source, right, IL is simply Vs over R total, right, because current I come out from the Vs, pass through Rs, right, and then go through RL, which is, well, we call it IL in this case, so therefore IL, okay, is Vs equal to R total, so Vs over Rs plus RL, because R total looking from Vs is, you can see that Rs is in series with RL. Okay, so this is your answer for IL. So, but now in this case, you have a current source, you have converted to the current source, like this, right? And we want to do the same thing, and we want to find IL that pass through RL right here. Okay, IL. Well, this is your Rs, correct? Well, I'm going to use current dividers, right? Because current I comes up here, right? and then it divided into IS, right? Let's call it IS, okay? And then IL. So this is IL. So if you recall, I hope that you recall by now, okay, without having to look back at your note, the formula for, what is the formula for IL using current divider? The formula current divider was IX equal to R total over RX, right, multiplied by IS. Okay, so therefore in these configurations above here, it would become, well, R total is simply, well, IS in this case is what? IL actually divided out from VS over R. So this is VS over RS. Okay, right? This current. Then your RX is, of course, wherever your IL. So therefore, it's like this. VS over RS, right? IL is whatever the current IL passed through. So it's RL. Okay, and R total is the total resistance that this current I has divided into. So it's this RS and RL in parallel. So therefore, R total in this case is RS parallel RL, which is equal to RS over RL, right? RS times RL over RS plus RL. Okay, so put it back there. It becomes RS times RL over RS plus RL. Okay, RL cancels, right? And RS cancels. So therefore, you have IL equal to VS over RS plus RL. Right? So therefore, it's the same answers as this one. So you can see that you get, when you convert from current source to voltage source, it sort of like give you the same answers. You didn't affect anything beyond that point AB, whatever the load you connected to. Okay, so that's when you change from voltage source to current source. Now to convert from current source to voltage source. Okay, so you have to realize that if you want to convert a current source, you must have this configuration. You must have the current source, okay, and you must have a resistor connected in parallel, to the current source. In that case, you can convert this to this so-called current source here with its internal resistance, okay, into the voltage source. And to do that, you have to write down your voltage source. Okay, your RS relocate again. So instead of being parallel, now it becomes series. Okay, series with the voltage source. And the value of voltage source using Ohm's law, V equal to IR or RI. Okay, V equal to RI. So therefore, you simply multiply RI and IS, and you get the value for your voltage source. So this is how you convert the current source to the voltage source. Okay, all right. So I'm gonna give a simple example just to show that how you do it. I got this sort of out of my son's bachelor degree university entrance exams. Okay, so I thought it's a good, it's simple, and it's sort of like it can be used to show how to do the source transformation example of it. Okay, so you have this circuit, and the question was to find I. Okay, what's I? Okay, so I'm going to show how we can convert using source transformation to make sure that you got this thing correct, right? So I look at this and I go, okay, I'm going to I see that there's 5 volts here and 2 ohms in series. So I'm going to convert this part into the current source. I'm going to also convert this part to a current source. So therefore, I will get I would redraw this. Okay, so it become current source. So resistor 2 ohms become parallel to the current source that I'm converted to. Okay, like this. So that's one set. The second set, of course, is this, right? 2 ohms in parallel with that current source. The current source become 5 over 2, right? V over R. So 5 over 2. Then the rest is still stay the same. Okay, 4 ohms like this. Then, of course, I know that, well, we all know that, well, when you have a current source in parallel, you can combine them together, right? So therefore, you get this one, right? Well, and 2 ohms also in parallel, right? They're in parallel. So 2 parallel 2 is equal to 1 ohms. And this become 5 half, add to 5 half become 5, right? So 5 amps. So you have this. 3 ohms here. So this become pictures like this. So now I see that, I have a current source and 1 ohms in parallel. I'm going to convert this into voltage source. So I'll get this, right? So my 1 ohm now is in series with my voltage source. And get this picture. So this become 5 times 1, which is 5 volt. Okay, so 7 ohms and this 3 ohm. So, and this is 2 volt. So you get this picture right here. So I can see that I have only one loop and I have a current I flowing like this. So I'm going to write down, KVL. Okay, KVL using mesh analysis or, in that sort of directions. So I'm going to start, let's start from here. I'm going to walk from here, go around as the current goes. So I see -2 first. So KVL for that loop I. So I see -2, right? -2. Then come here, right? Voltage drop across 3 ohms, right? 3 times I. So we drop across 3 ohms. So therefore is plus 3I. Okay. Come here, right? Plus 7I. Okay. Comes here, plus I. See positive 5 plus 5 equal to 0. 4, another 4I. Come here, 4I plus 4I plus 4I equal to 0. So therefore, let's see, 7 plus 3I, 10I plus 1I, 11I plus 4I, 15I. 15I equal to 5, right? Minus 5, okay, plus 2. Okay, so therefore I is equal to minus 3 over 15 or minus 1/5 amps. Okay, so therefore you get your answer as your current I. Okay, so this is an example of how we, which connections when you transform it, and be careful, you have to know which direction is your current. Okay, which is your current. If you look up here, you see that, well, if the current go up like this, wherever the head of the arrow is, okay, when you transform into the voltage source, it's a positive, terminal. Okay, positive terminal. Okay, so be careful with those. Okay. So therefore, this is a very short topic. This is it for the idea of source transformation. Okay, thank you.